All right, my macro friends, let's work on question number 4 for this homework assignment. I called up right here the question I posed to you. Now, suppose we're analyzing a slightly different economy. Specifically, the new economy is identical to the old every way, all right? So it's a copy paste. One thing is different. C1. That parameter C1 in this new economy is 10% greater than in the old economy. You can assume that this new value of C1 holds in both periods for the new economy, both T1 and T. So I'm asking you to do a couple of things. What was the change in consumer spending in each of these two economies? Find the delta and percent delta over those periods in the respective economies. Why was the change in spending different? What fraction of spending in the consumer was due to the change in Y in the first economy and within the second? So for that, you really need to understand what is the C1. I have a lot of Excel work for you. I'm going to demo all of it, but to answer this first question, let's scroll on down. I'm going to hover over this box, consumption, C0, C1, Y minus T, C2, R. That's the standard consumption function we've played with. Now, remember, parameters, the little c's, 0, 1, and 2 are all parameters, which means they're numbers that have to be calibrated. We treat them as positive constants or non-negative. C1 is right in front of Y minus T, Y minus T, income minus taxes, disposable income. So if it's right in front of disposable income, consumption is equal to some stuff, including disposable income. If disposable income goes up, look, there's a positive sign in front of C1, means that as disposable income goes up, consumption goes up by how much? C1. C1 is the sensitivity of the consumer to changes in disposable income. Or for my calc people, take the partial derivative of C with respect to disposable income, you get little C1. And we know every partial derivative is like a sensitivity, almost like an elasticity. All right, so now we know what C1 is. Let's go back up. Let's go back up to the question. So you got these two economies. They're the same in every way, but for some reason, some of the people in this new economy, they have a different sensitivity to changes in disposable income. Sorry, I'm getting my tea. I need my tea. They got a different sensitivity to the changes in disposable income. So we want to know if people are different, how are they going to respond to this type of shock? Now, the shock we already talked about is impacting income and thereby disposable income. So, what we're talking about is not the difference in the shock itself, but people's reaction and their sensitivity to the shock. All right. So, we have to figure out a way to do that. Your job to set this up. The way that I did it was I copied and pasted the architecture of the template that I provided to you, left and right. I'll call it A and B, old and new, whatever you want to call them. Chapel Hill and Durham. All right, so you already had the calibration of alphas, betas, deltas, the shocks, the exogenous variables, and the equilibria I already filled in for you. And then, of course, you got the gaps, Y gap, I gap, R gap, and then the nominal interest rate. I also have some structural variables for you. You don't need all of them. You don't need I, G, or NX in our particular example. I'm going to focus on consumption because it's C1 that is changing. All right, so what happens? You got, given the calibration, epsilon PC of 4. We want to see how this economy reacts to it. You can even set it to 0, and you can watch how it reacts, right? It's 0, and you can watch how it reacts. Particularly, you got a decline in economic activity. You have an increase in high inflation and an increase in that real interest rate. We've already told the story economically as to what's going on behind the scenes, right? Supply side shock, PC up. That means it's adverse. So that's the decline in economic activity. Since it's adverse, an increase in inflation, Federal Reserve Monetary Authority reacts, and interest rates are higher. All right. So we got that story. To do a little bit of mechanical work on it, we could start taking a peek at those partial derivatives, which we have played with before. Not essential for now, but just to get your exercise in. You think about the equilibrium Y with respect to the shock and the Phillips curve, and you could go to a formulas, you take the partial derivative. I keyed it in for you there. The piece that's different than just taking a partial derivative is that we need a number. So we discretize. That's why I'm multiplying by D9, which is the change in the Phillips curve shock. So that means that we would expect the change in disposable income, given the size of this shock, to be minus 1.875. Hey, look at that. See where my cursor is? That's exactly how much. I mean, due to a rounding, if we took over the number of digits larger and larger, this is a numerical proxy, but that would be good. Okay, same thing here. How much does the interest rate change due to this shock? Take the formulas for our closed form model, which are up on the market observatory side. You go ahead and you take a discretization, multiply by the size of the shock, D9, and you get pardon me, plus 0.1875 empirically, which matches what we got analytically. All good. So now that doesn't answer the question, but I do want to show you over here. I copied and pasted the economy. And the only thing that's different is C1, which I'll show you in a second. But look at this. No changes in formulas, no changes in economic activity either. So when I'm just thinking about the reduced form structure, this change in consumer behavior in our model apparatus is not impacting the economy in aggregate. It's impacting perhaps the allocation of economic activity vis-a-vis the structural representation through the consumption function. Now, if we had a complete system, any changes in the structural parameters should be reflected inside of those reduced form. We're not doing that. That's laudable. We could do it. We're not doing that in this instance. That's not the point at which we are at in your training. So come on down and we think about the structural differences. Let's take a look. 10.56, follow the cursor, 10.56. 2.5, follow the cursor, 2.5. And 14. 14. So what that means is that C1, pardon me, C0, C2, and T are all the same in left economy A, right economy B. The only thing that's different is in the new economy, I'm going to take the old marginal propensity to consume, which is C1, and increase it by 10%. And that's what the instructions told you to do. The template I provided wasn't set up that way. That was for you to discover and engineer and create. Okay. So take a look. Let me scooch over so you can see them both. Let's compare. Let me see if I can highlight these for you. In red. Okay. Take a look at what's highlighted in red. These are the changes in consumption due to the same shock, PC, same magnitude shock, 4. On the left is the original, and it was down 0.6187. And over here on the new one is minus 0.6337. So we had already said that C1 was the sensitivity of the consumer to changes in disposable income. The change in disposable income is the same, minus 0.1875 in both economies. So all we're doing is saying these consumers on the right are more sensitive to that change in disposable income. And as a result, their consumption is changing by more. Okay, so that matches our intuition empirically. Now take a look at this. Take a look at this. The minus 0.6187 translated into a minus 0.861% drop. So you can think of one as dollars and the other as a percentage change. Well, the percentage change here is minus 0.085, so it's less. The answer that we get if we look in dollar terms is different than the answer we get if we look in percent terms. So did I get the logic wrong? No, not really. The logic we got is sound. Look at the base. We're going from 71.86 to 71.24. Here we're going from 78.74. So the base is different, which means the percentage change for any dollar amount is going to be different. So it's difficult to compare. Now, again, it doesn't mean that our logic is wrong. We need a sharper way to see how much of the change in consumption was due to the change in this shock in disposable income. That's where handy dandy partial derivatives are going to come in. I'll show you two ways. One is with actually with that partial derivative, and another I'll show you an empirical, perhaps more intuitive way to think of the partial derivative if you're not calc minded. Okay, so let's call this back up. Hopefully in the share screen, you can see the consumption function. Again, C0 plus C1y minus T minus C2R. What does C1 mean? If I change disposable income, how much does consumption change? And if disposable income falls, that means that consumption should fall by the amount C1. So I'm going to try to do two things. I want to figure out what was the change in disposable income and then multiply it, amplify it, scale it by C1. Okay, again, take that change in disposable income, that dollar amount, and then scale it by C1. I'm referencing D18, which is the change in disposable income. Now, it's only changing Y. Okay, but T is exogenous and fixed, so it's the same thing in terms of a delta. Multiply it by, scale it by that sensitivity, which is going to be the C30. That's going to give you minus 0.15. All right, so that's how much consumption is moving because of this change in Y or the disposable income. If you're not calc minded, that maybe that doesn't make sense. So let's scroll on down. Let me see if I can zoom in for you. All these partial derivatives you can think of as nothing more than a numerical proxy. If you're hitting something in the partial derivatives, you're hitting whatever's on the bottom, how much does the thing on the top move? So what I did was I built a consumption function. Let me scroll up so you can see what these things are referencing. They're referencing the C0, C1, C2, the T, and the R. All the bits and pieces of the consumption function except for one, which is the Y. I'm going to feed in the Y from column A, 50. So that's our consumption function. And then I'm going to take those same parameters, but feed in now A51, a new level of income, which is 1 unit higher. And the same parameters, but 1 unit higher. And same parameters, but 1 unit higher on Y. So what I'm doing is saying, tell me how much you would consume for a given level of consumption. Now, pardon me, income. Now, increase income by 1 unit. How much did your consumption change? Increase it again by 1 unit. How much did your consumption change? We assume a linear consumption function, which means the slope is the same everywhere, which means it should always go up by the same amount. How much did consumption change? Scaled by how much did output change, her income? That, my friends, is zero point 0.8. That, my friends, is 0.8, 0.8. In fact, 0.8 and zero point 0.8. So that's per unit. That's for a given change in output, a 1 unit change in increase in output. But, well, how much did output and income actually change? Well, we want to scale that by the amount. Let me scroll up so you can see D18. So I'm going to take that per unit amount and scale it by the size of the shock. So that gives me minus 0.15, no matter where I am, because again, it's straight line. Okay, so minus 0.15 in this sort of empirical way that you could have done through just sample testing, trial and error matches the analytical approach we got from the partial derivatives. All right, now what you could do is do the same thing for R. Now think about what that's doing. It's taking C31, which is the C2 parameter. That's the sensitivity of consumption to the change in the interest rate times the amount of the change in the interest rate in D20. Why is there a negative sign there? Boom. Mathematically, look, it's minus C2, so we needed to accommodate for that. Same structure as before, and I also have an empirical way of thinking of that as well. I did the same exact setup. I took a consumption function and I'm referencing different interest rates, all increased by 1 unit. I take the scaled amount on each of them, and then I amplify that by the amount of that shock. And I get minus 0.4688, which is minus 0.4688, exactly what we got when we did it from an analytical structure. You take the change in consumption due to Y, the change in consumption due to R. You have all the movements of the endogenous variables. You put those together and up to, you know, thousands, 4 decimal places, you get exactly what we had there. From that, you can figure out, well, how much of the change in Y was due to the Y, pardon me, change in C was due to the change in Y, change in C due to the change in R. Those add up to 100 because it's percent. So we really dug into the reason, the amount, the direction of the change in consumption under the original economy with the marginal propensity to consume equal to zero point 0.8. Scooch on over. Over here, we have the same exact structure, architecture. All the formulas are the same, but they're linked to the new framework, which is the new marginal propensity to consume. I want to see if I can get both of those on the same screen. Kind of. Okay, so take a look. I got minus 0.4688, minus 0.4688. There's no difference. Why is that? For the interest rate, we have the change in the equilibrium interest rate and the sensitivity. Both of those are the same. So the size of the shock, the amount of this that's due to the change in the interest rate is the same. All that's changing is over here. I'm linking to the same amount of change in income, but now there's more sensitive. That multiplier, referenced in cell L30, is bigger, which means it's declining by more. All else the same, that means that the fraction is bigger. The fraction of the total change in consumption due to Y is larger. So take a step back and you look at the question again. We had come on, get the whole thing. There we go. We had two economies identical in every way. The only difference is the change in C1, that amount of sensitivity, margin propensity to consume, differs in this new economy. When there's this shock that's adverse in reducing income, the people in this new economy are going to respond by more because they're more sensitive, even though the size of the shock is the same. Hope that helps.